Hi, in this video, we'll continue discussing the properties of logarithms. In the following properties, m and b are positive real numbers, and b is not equal to 1, and r is any real number. So remember that these letters mentioned are positive real numbers, m, n, and b is not equal to 1. So we have property 5.5, and this is called the product rule for logarithms. So it states that the logarithm of the product with base b is just equal to the logarithm of m of b plus the logarithm of n of base b. So you can just, to get the logarithm of this with base b, just simply get the logarithm the logarithm of each individual factors. So you get the logarithm of m with, of course, with base b, and the logarithm of n with base b, and add them if that's the product, if this is just a product. So make sure that m and n are being multiplied. Now write the sum. So example, write as the sum of logarithms. So what we will do here is we will just express this one as a sum. Okay, so to do that, we apply the property, taking note that m here is our x squared, and our n here is the square root of the quantity 1 minus x. Okay, remember, this is our m and this is our n. Okay, we will apply this one, so this becomes, so with base b, remember that this one and this one are being multiplied. Okay, so this becomes, according to the property above, this becomes logarithm of x squared with base b plus logarithm of quantity of 1 minus x with base b. So now we already expressed this expression as a sum of logarithms. So this is just a sum of logarithms. So we're done. So we are just applying this property. Okay, another example. We have this one. This is number 1. Another example. So to write this one as a sum of logarithms, all you have to do first is to express this expression right here as a product. Okay, so we cannot apply this one because it's not, the expression here is not in factored form, so it must be factored. So in this case, it must be factored first so that we can apply the property. Now to do that, we have to factor the expression inside first. So that becomes, remember, x squared minus 9. When you're going to factor that one, that is equal to x minus 3, x plus 3. We have base b. So now we are ready to apply the property. Okay, these are already factors. So this becomes our m and n. And of course, to apply that one, that becomes log x minus 3, then b, plus log of x plus 3 raised with base b. Okay, so the answer is this one. So we already expressed this one as a sum of logarithms. Okay, another property. So we're done with product rule. Next is the quotient rule. So it's very similar to the previous property, but this time make sure that our expression here looks like this. So it should be in this form, m over n. So that is equal to the logarithm of m, of course with with base b, if quotient, that is minus. So that's logarithm of n of exponent b. So that's the property. So make sure that the expression here inside um, should look like this. So it should be in that form. So example, we have this one. We are going to write as a difference of logarithms. So we have log base b logarithm of x cubed over the quantity of x plus 5 raised to 2. So as you can see, this one is m and this one right here is our n. So meaning this one is in this form, so we are ready to apply the property. So it's really straightforward. So the answer is x cubed minus the logarithm of with base b of x plus 5 squared, the quantity of x plus 5 squared. So we've already expressed this expression into a difference of logarithms. So we're done with our example. Okay, another example. A cube root of quantity of x over x plus 9 with base 5. So to do that, of course, make sure first that the expression here looks like this, but it's not. So you have to rewrite this one as an expression having this form. So we will apply some properties for radicals. So this becomes log with base 5. This becomes cube root of x over cube root of x plus 9. Remember the property for the radicals? So that is equal to, so since this one is already in the form m over n, this m over n, so we are ready to apply this one. So now this becomes logarithm of base 5 cube root x minus logarithm of base 5 x plus 9. Okay, so we're done. We have already expressed this expression as a difference of logarithms. Okay, so this difference. So it's quite easy to apply this property. Okay, another property. This is called the power rule for logarithms. Now, in this property, it simply states that the logarithm of m raised to r with base b is just equal to r times the logarithm of m with base b. So basically, uh, if this is the form of your expression, this is always equal to the exponent. Okay, you can just pull this exponent out and then multiply it to the logarithm of m with base b. So for example, we have this one. Let's say you have 5 raised to 2 with base 3. So this is just equal to 2 times the logarithm of 5 with base 3. So that's the power rule of our logarithm. So just pull this expression out, and then what you're left is here is this one. We will use the properties what we have learned so far. We have power rule, we have the quotient, the product rule, as well as all those properties. Property 5.3, I and 2I, and 5.4. Okay, so what we will do here is we're going to write each logarithmic expression as a single logarithm. Okay, so as a single logarithm. We will do that in our next video, so please stay tuned for the next part. Again, we will apply the properties we have learned so far in order for us to write the expression in A, for example, as a single logarithm. So please stay tuned for the next video. Thank you very much and have a nice day.